In this lesson, we're going to be looking at basic trig identities. Before we look at the trig identities, it's important to understand what an identity is. It's a statement of equality between two expressions that is true for all values of the variables for which the expressions are defined. We have the reciprocal identities, which says the sine equals 1 over cosecant, cosine equals 1 over secant, tangent equals 1 over cotangent. Cosecant is 1 over sine, secant 1 over cosine, and cotangent equals 1 over tangent. Quotient identities say that sine over cosine equals tangent, and then cosine over sine equals cotangent. The Pythagorean identities are derived from the Pythagorean theorem. Sine squared plus cosine squared equals 1. And if we divide each one of those, both sides of the equation by sine squared, we get 1 plus cotangent squared equals cosecant squared. If we divide both sides of the Pythagorean identity by cosine squared, we get tangent squared plus 1 equals secant squared. And then these are the symmetry identities. All right, so if you were to reflect or rotate these identities, these trig functions across some line, you would get the trig function on the right side of the equation. Same thing for the cosine. These symmetry identities are essentially the resulting trig function whenever you rotate or reflect these trig functions. If you add or subtract pi over 2 to any trig function, you're basically just rotating it 90 degrees. And then lastly, sine of a negative angle measure just equals negative sine x. Then cosine of a negative angle measure is just going to be cosine x. All right, so if it's given that cosecant equals 1.03, and we want to find secant of that same angle measure, rotated pi over 2 degrees in the negative direction, using the symmetry identity. That would result in, so using the identity secant of theta minus pi over 2 equals cosecant of theta. The secant of that 1.03 angle minus pi over 2 is still going to be 1.03. All right, for the next example, we need to basically plug in the statement on that second line. And to get the statement on the second line, we need to decompose the secant plus 1 into sine and cosine. Secant is 1 over cosine. So we're just going to replace the secant with 1 over cosine and then the plus 1. For this one, we have to do that twice. So to get the statement in that second line, we need to decompose the statement in the first line into sine and cosine. So since secant is 1 over cosine, we're going to replace that with 1 over cosine squared. And cosecant is 1 over sine, so we're going to replace that with 1 over sine squared. And then looking at the third line, the reason for the third line, to get the statement for that fourth line, we're going to replace the sine squared plus cosine squared in that third line with 1.